All right, let's talk about the second half of our lesson about radicals. We've already talked about multiplying radicals. Now we need to talk about how to divide radicals. Now, dividing radicals is fairly simple. We're always going to simplify the radicals first, take out any perfect squares we already see, cancel between radicals. Remember when you're canceling, A always has to be multiplication, and B, you cancel coefficients with coefficients and radicals with radicals. And just watch out for that addition, and I'll point that out as we go along. And then we have to do a strategy called rationalizing the denominator. You can never leave a radical in the denominator of a fraction. It's just bad math grammar. So you always have to go through a process. It's going to look a lot like making a common denominator for adding or subtracting fractions. So here we go. In our first example, the square root of 9 can be simplified to 3. The square root of 16 can be simplified to 4. And we have a very straightforward problem of 3 over 16. There are no common factors. We don't have to do any reducing. Now this next example has a great learning point about canceling. It's very tempting to want to cancel this 4 with that 4. This is an addition problem in the numerator, and you cannot cancel. So what we want to do first is we want to check if there are any radicals that can be simplified. Square root of 3 cannot. The square root of 4 can be. So I'm going to leave my numerator like it is. And I end up with 4 times 2 in the denominator. Now again, it's very tempting to want to cancel that 4 and that 4, numerator, denominator, but you can't because it's still an addition problem. We additionally want to look to see if there are any common factors in the numerator, any common factors between 4 and 3, to see if we can factor our numerator. We can't, and so our final answer is 4 plus 3 radical 3 all over 8. Now our next example is going to have a couple of different issues in it. First, we check for canceling. 4 and 5 do not have any common factors. I can think of these two numbers as being under the radical together. And so I can actually think about this as the 4 times the square root of 3 times the square root of 5, if I just factor 15, and 5 times the square root of 3 times the square root of 2, if I factor 6. This helps me see that both of these have a factor of square root of 3 over square root of 3. Remember, it must be identical. You cannot cancel 3 and the square root of 3 because those are not the same number. So at this point, I have 4 radical 5 over 5 radical 2. This is where rationalizing the denominator comes in. I cannot leave this radical 2 in the bottom. So what I'm going to do is I'm going to multiply by radical 2 over radical 2. Now radical 2 over radical 2 is really 1. So I'm not changing the numerical value of my problem. I'm just changing the way it looks. So what I have now is 4 radical 10, radical 5 times radical 2, all over 5 radical 4. What is radical 4? 4 radical 10 over 5 times 2. And what often will happen when you rationalize the denominator is you end up being able to cancel. And so my answer here is 2 radical 10 over 5. Now my next example has some variables in it. And I have a choice. I can either take the square roots of the different problems as able, or I can go ahead and simplify. I'm going to go ahead and simplify first. So I'm thinking about these here. 3 and 5 don't simplify. So the 3 is going to stand to the radical, and the 5 is going to stand to the radical. X and x squared have a common factor of x, so the numerator cancels, and 1 cancels, leaving 1 in the denominator. Y to the 4th and y squared cancels, and that leaves 2 in the numerator, and that leaves me y squared in the numerator. Now to just recover those cancels, remember x over x squared is really like x over x times x, where this one and this one cancel, leaving the 1. And y to the 4th is like that over y squared. So these two cancel with these two, leaving y squared. Now this numerator can be simplified because the square root of y squared is y. And I have that radical 5x in the denominator. So I need to multiply top and bottom by the square root of 5x over the square root of 5x. Whatever your radical is in the denominator is what you use to rationalize. I don't care about the 2. The 2 can stay in the denominator because that is a whole number. So what happens here in the numerator, I have y square root of 15x all over 2 times 5x, because radical 5x times radical 5x is really 5x squared, square root, and the squaring and the square root cancel. And so I have y square root 15x all over 10x. Again, it's tempting to want to cancel those x's, but the numerator one is under the radical, and so you cannot cancel. Now my last example here initially looks kind of hard. And again, it's tempting to maybe want to cancel this radical 3 and that radical 3, but I can't because of that addition. Since nothing can be simplified, I'm going to go ahead and multiply by radical 3 over radical 3. But in the numerator, since I have a sum, I have to remember to use parentheses. That's a single number, which means I'm going to have the distributive property. So in the numerator, I have 3 radical 5 times radical 3, which is going to give me 3 radical 15, plus 3 radical 3 times, radical 3 times radical 3, it's going to be radical 9, all over 5 times 3. Radical 3 times radical 3 is just 3. Now I'm going to clean up this numerator. 3 radical 15 plus 3, square root of 9 simplified, over 5 times 3. Now I didn't multiply that out for a reason. I don't have to rationalize my denominator here because I already did, but I see a common factor of 3. Now I've emphasized you can't cancel across addition, so what we have to do in that numerator is we have to factor it. And factoring is undoing the distributive property. The distributive property is multiplication, so when I undo it, I'm dividing. So if I take a 3 out, and when I say take out, I'm taking it out by division. So my little baby problem in my brain is I take 3 radical 15 divided by 3, that leaves radical 15, plus 3 divided by 3 leaves 1. If you do the distributive property after you factor, you should get back to your original. This is all over 5 times 3. You see now my numerator is a number 3 times a quantity. It's now a multiplication problem. Cancel, cancel. The square root of 15 plus 1 all over 5. That is your final answer. Now, solving with equations with radicals is just like Algebra 1 with one new step. You're going to isolate the radical by using opposite operations, just like we isolate the variable when we're solving. We're going to undo the roots by squaring or cubing, depending on whatever root or power that we need. We're also going to watch for extraneous solutions, and extraneous solutions are those answers that show up that might make our original problem false. So in this case, any value that would make whatever's under our radical negative. So first problem, we need to subtract away 1. The square root of x is equal to 3. And here's your new step. To undo square rooting, you square it. And you end up with x is 9. If I take a quick peek back to the original, 9 will go in there just fine. That is all there is to doing this. Example 2, this -6 is being multiplied to my root, so I'm going to divide -6 by both sides. So the square root of 12r is equal to 6. Now it's tempting to want to divide by 12, but 12 is under the radical sign, so I cannot get it out until I square both sides, and I end up with 12r is equal to 36. Now I can divide by 12, and r is 3. In my next example, there's nothing to move away first because I have radicals on both sides. And so if I simply square both sides, I end up with -3 minus 2v is equal to 2v plus 9. Get your v's together, get your constants together. And v ends up being -3. In this last one, second to last one, again, square it first, both sides, and -10 is equal to 16. Add 10 to both sides, and is 26. And in our last example, -6 is being subtracted essentially, so I'm going to add 6 to both sides to undo that. And I have 1 is equal to the square root of a over 2. Even though it's a fractional root, it doesn't matter. I still square both sides. 1 is equal to a over 2. We undo division by 2 by multiplying by 2, and 2 is a.